And I want to thank everyone for joining us this afternoon or evening, depending where you're at. When we give these presentations, we typically like to do these in person. And usually before I get started, I like to get an idea of how many people are in the room. And then because I'm not very good at math, I like to do some very simple multiplication. Each one of you could be doing something else right now, but you've chosen to give us a few minutes of your valuable time, and we appreciate that. So I like to come up with a round number of what your time and everyone else on this call's time is worth. And usually what we come up with is a very expensive call. And that makes me very honored and humbled that you joined us. And I will do my best over the next 30 to 40 minutes to earn that time. So this is part one of a two-part session. Next week will be part two on Tuesday at 8:30 a.m. and Eastern time, and Thursday at 6:30 p.m. Eastern time. In those presentations, we're going to take a closer look at things like mock panels, flashings, transitions, and other details that are important for a successful residential or commercial project. We are fortunate to have Chris Hines working that chat box today. Please throw some questions in there as they come up. He's the guy I often go to when I have questions. So you guys are in great hands today. Thank you, Chris.
Thank you, Jeff.
You bet. So I put a small picture up there. Typically when we do these presentations, we're in a conference room, a warehouse, some other setting like that. We'll have a demo board. We have a PowerPoint presentation, but it ends up being much more of a conversation. And I think you'll find that in this presentation, there will be good information for anyone that's involved in manufactured stone, a builder, a dealer, an architect. But this is definitely geared towards the mason and the contractor. That's where I started my career. And I think what you'll find is that the title says it all. We call this a warranty and code review warranty. So what does it take to meet a manufacturer's warranty? And then what are the code minimums? What we don't want to happen is for someone to have completed a job, there be an issue, and when the manufacturer reviews the photos or reviews the job, finds out that there was a misstep, and that misstep voids the warranty. The other thing that we don't want to happen is some type of a code violation. In this picture, you can see that the metal lath is not overlapped, and as that wall warmed up, that ends up causing some cracking in the stone. And so code violations like this, or taking things into grade, situations that end up in tear off and repair. So we'll cover a lot of that today also. We'll cover a lot of information. Again, please throw your questions in the chat box. Since I can't see you raising your hand, just a couple of slides on Boral. If you're not familiar with Boral, it's a company that's based in Australia, works also in Asia and the Middle East. In North America, we're more of an exterior cladding company. Doing everything from clay and concrete roofing tile, trim, siding, windows, brick, and obviously manufactured stone. I'm fortunate to work with all 5 of our manufactured stone brands. If you are interested in some of the other products that we work with, please check us out at boralamerica.com. So let's set a foundation for our conversation today. We're going to be talking about adhered veneer stone or manufactured stone. There are some code requirements for manufactured stone for the units themselves. Typically, most codes are running off of either AC 51 or ASTM C1670. They're going to call out things like the thickness of the product. Can't be any thinner than 1/4 of an inch. Can't average any thicker than 2 5/8. Can't be any larger in one direction than 36 inches. The piece itself can't be any larger than 5 square feet. An important one is going to be this weight issue, 15 pounds per square foot. It's important that the product stays at that or less because the total weight available for the system is 25 pounds, and we need to allow that extra 8 to 10 pounds for the lath and scratch coat, but the material itself can't exceed 15 pounds. They're going to do some testing on its compressive strength, freeze-thaw cycle, making sure that that stone is able to stand up in some of the harsher climates in different parts of North America. Making sure that the back of that stone is able to achieve a 50 PSI for bond strength. I apologize that this slide, the words are a little bit small. What I wanted to do was show that all of the stuff for an adhered veneer pretty much fit on one slide. If you were to look at other materials, often they would probably take up 2, 3, 4 slides to have all the information. But right now, adhered masonry veneer will fit on one slide. It's got information on your water resistant barriers, on flashings, on your foundation weep screeds, clearances to grade. And a lot of time what they're going to tell you to do is jump out to a different section. So don't worry about reading that. We've gone through and collected a lot of that information and put it together into this presentation. The one thing I would point out is it often says in the building code, whether the international building code or sometimes your local code, that the adhered veneer should be installed per a section and the manufacturer's instructions. Anytime you see that in the code, that essentially makes the installation instructions of the product you're using part of code. If you're using a Boral product, we'll be looking at the NCMA-MSV installation guide. That would be a great reference for any of our stones. But my caution would be if you're using another brand, make sure you reach out and grab their installation instructions. If they have their own, make sure you look through them to see if there's anything different to make sure that you're covered. If you're not familiar with the NCMA, that is the Industry Organization for Manufactured Stone. The Organization for Manufactured Stone was formed back in 2006. We're now part of the National Concrete Masonry Association. They published their first installation guide back in 2009. We're working on the most current edition that came out late last year. This guide is what helps us make sure that we comply with ASTM-C 1780. That is the requirement for installation of adhered veneer. If you don't have a copy of this, go ahead and jump on any one of our stone websites. In the installation part, there will be a link that will take you out to it, or you can go to ncma.org and hop into their manufactured stone section and find the guide. I would recommend downloading a copy and at least keeping it on your computer. If you're a contractor, keep a copy of it in your vehicle, in your truck. I can't tell you how many times I've gone to it as a resource. There's about 10 pages of phenomenal information around papers, laths, mortars, wall prep, and then about 40 or so details on flashings, transitions, and things like that. And I think in most cases, contractors have a pretty good idea what to do. Occasionally, they might get into a situation where they're not sure, or often it's a transition point between two different claddings. And this is a great place to go and get information to make sure that we're making that transition properly. Anytime we have one of these conversations that we talk about code, we want to make sure that we put a note out that we can't cover all of code. Sometimes local codes will vary. So make sure that you check your local codes. And then when it comes to project site requirements and safety, we believe every one of our employees deserves the right to go home in the same shape they came to work each day, and we believe that for everybody we come in contact with. I was sent this photo for another reason. I'll be honest with you, I couldn't get past the fact that these guys are 10, 12 feet up off the ground with no bracing behind them. I can tell you that back when I was installing, I probably would have built my set like this and probably been standing on top of that yellow bucket. That's absolutely the wrong thing to do. You know, I love manufactured stone, but tripping on one of those stones, falling and injuring yourself is definitely not worth it for a manufactured stone project. So please be safe out there, look out for each other. My last note around safety is around the silica regulations. Manufactured stone, just like brick, just like natural stone, just like landscaping products and any concrete, has silica in it. And when you cut it, if you're not using the proper saw, it's going to kick up this white dust. That white dust has silica in it, particles in it. Those particles have little hooks on that when they get into our lungs, stay there. They're not like other particulates that when you cough, you're able to kind of expel out. And those particles do have the potential to cause cancer. So make sure you're wearing the proper respirators, using wet saws and vacuum saws when you do any of that cutting. The last piece that I want to set as our foundation is around moisture. Vapor, liquid water is constantly moving in and out of our buildings. I would suggest that really every cladding leaks. It's how prepared are we behind the cladding to deal with that moisture. You don't need to read all these little things here. They came from a company called Dorkin. Some phenomenal information on things like HVAC, how that moves vapor through our walls. Wind effects on our buildings can do that. If it's hot outside and cold inside or vice versa, that will cause vapor to move through our walls. And then obviously all the different rain events that happen. I took this picture of a hotel that I was staying out. It had not rained. That was first thing in the morning, walking out to probably about 98 degrees and about 95% humidity. But the inside of that building, when the air conditioner was running, had very low humidity. And you can see the moisture trying to work its way into that wall to get inside of that cooler, dry air. This was a building next to another hotel that I stayed at. I don't know how confident you are in that water resistant barrier. I'm not very confident at all. I don't know if you can see there's a little bag in there that seems to even be catching water. And then finally this one, again, walking out of a hotel, this was a building next to it. You can see that OSB is completely saturated. If you could zoom in on some of the taping around that window, it's already starting to peel loose. I guess they could go out and redo all that stuff and make sure that it dries out before they apply to it. But those types of issues can be a problem. And I know when we look at this as a stone installer, we think, well, that's not my issue. But I'll tell you that 9 times out of 10, if there's a moisture issue inside that building, that first phone call is going to go to the stone mason. Why? Because the stone leaked. Again, I'll suggest that pretty much all claddings leak. And I will tell you that manufactured stone is definitely not waterproof. It's the job of that primary WRB and the flashings and all those openings and penetration. When those are done right, that's what keeps water out of that building. So I think to some degree, we as contractors, we need to get back to being those cranky masons and contractors who do a really good job of inspecting the project before we get started and going on record if something isn't right. I was sent this photo because of the cracking that the contractor was pointing out in the stone. Again, I had a problem getting past this area up here. You will notice that the tape that's being used to tape off that window, I don't believe, I'm not a window guy, but I don't believe that's the right one. They did have 2 layers of WRB. We can see the white house wrap and then a second layer of a black paper. But then they went through and put a flashing on. This flashing is required anytime we transition between 2 dissimilar materials. We need a horizontal flashing there to take any of the water from above and dump it out so it doesn't get back in behind the cladding below. But unfortunately, they nailed that flashing on top of the 2 layers of paper. It's called reverse flashed. Now, if any water gets back in behind our cladding above, it's going to travel down, and I guarantee it's not going to jump off the white paper onto the black and then onto the flashing. It's going to get driven behind the stone, and in 3, 5, 7 years, when the OSB or plywood behind there is deteriorating and the mason gets called, that's what we'll find was the issue. So they either should have cut the primary WRB to tuck this in underneath, or gone through and put some peel and stick tape on there. And again, we should default to the primary WRB manufacturer's recommendations on how to do that, but some way to channel that water out so it doesn't get behind our material. So let's get started. We're going to split our presentation up into 2 sections, wood and frame construction and masonry construction. Let's start with masonry. We'll define that as a CMU poured wall or tilt-up wall construction. As long as that masonry is clean and bondable, you can put a stone directly to it. What do we mean by that? Well, we need to make sure that there's no paint, no sealer, no form release. Things like dirt and dust that have splashed up off the ground onto masonry will inhibit the bond and they'll break the bond. So we need to make sure that that masonry is clean and then bondable, meaning that it's not so smooth and hard that mortar can't make a bite into it. So in this NCMA guide, there's these wonderful details or tables that will take us through all the different backup systems and then what may or may not be required to install over it. So another reason to keep that guide handy. One of their details shows a brand new CMU wall, and as an option, they're saying you may want to put metal lath over top. One of the reasons is movement cracking. You can see, if you look close enough, some step cracking in this CMU. If I had installed my stone directly to that CMU and that CMU step cracked, it would have passed through my stone. If I had shot some metal lath over top of it, that metal lath acts as a bond break, absorbs a lot of that movement, and typically doesn't pass all that cracking through to the stone. If you're going to put metal lath over top of CMU, we're looking for a very similar nail pattern that we do for framed construction. We want it 16 on center, about every 6 to 7 inches vertically. Our other concerns around masonry is they can move at a different rate than a manufactured stone, especially a CMU and a brick have a tendency to expand and contract when they get wet or as they dry out at a different rate than a manufactured stone. And so it may be a good idea if you're concerned with that movement to use metal lath. The NCMA guide does spend some time around poured walls and tilt-up construction because of the form release that's on there. They point out to the International Concrete Repair Institute, they've got a technical guide specifically pointing to how to prepare the masonry surfaces for different applications. For manufactured stone, we would say you need to have a concrete surface profile or a CSP that's equal to or greater than 2. Now, what does that look like? Well, they have a guide that'll show you what a CSP1 looks like, and that essentially uses acid. Now, on a poured wall or tilt-up wall, that's probably will do a good job of getting the form release off. But it doesn't roughen the surface enough for the mortar to bond to. It's still too smooth, a little too much like glass. So you're going to need to, at that point, use some type of grinder to roughen up that surface. That sounds like a lot of work to me, especially considering all the OSHA regulations around silica dust. So another option that I think makes a lot more sense would be to use a Tapcon or a ram set to shoot metal lath over top, or I don't sell for them, but Senko makes a gun that runs off an air compressor and will shoot a masonry anchor. And the nice thing about an air compressor is you can adjust that pressure if you're shooting into CMU with a lower pressure, or higher pressure if you have to shoot into a poured wall or tilt-up wall, but get that zoned in to the point where you're not blowing the masonry apart when you shoot that anchor in. I think we've all seen it, what it looks like when we put stone over top of a poured wall without getting that form release off. It takes a good 6 months or so, but eventually stones start sliding off the wall. It really doesn't take any pressure with your hand just to pop them right off. If you're not from the Midwest or the East Coast, you're probably not seen this before, but it's a poured wall foundation where they put a brick texture into the molds. The contractor thought that texture would be enough, but I'll tell you, it still is extremely smooth and hard. The mortar was not able to bond with it, and you can see how sheets of stone fell off of that wall. Let's take a look at expansion joints and control joints. If you're working over a building that has expansion joints, movement joints that go all the way back into the building, you should not install manufactured stone over top of it. The contractor did the right thing. They stopped and started again on the other side. The only mistake was they went through and shot some grout in here. You can see the hairline cracking that's developed there. Now we've got an entry point for moisture and bugs. They really should have left that open and then come back through with baccarat and sealant in most situations. Now, when it comes to control joints, the manufactured stone industry right now does not have specific requirements like we see with some other claddings for control joints. Now, that doesn't mean that they may not be necessary. It's just at this point, there isn't specific direction on where they belong. If you have a masonry structure or a wood frame structure, there still are places, like in this example, where they've got some really tall metal windows. That metal is going to expand and contract a lot. And so it may make sense to put control joints off the corners of those windows. In this case, this was a wood frame building going up 4 or 5 stories tall. That is probably some 2x4s and sheathing that's fairly green, wet. And then we hang our stone with an extra 17 or 20 or up to 25 pounds per square foot of additional weight on that wall system. Now, what's going to happen over the next 6 months to a year as that wood begins to dry out? Well, it's going to dry out. That means it's going to shrink, and there's potential for that building to compress. It could lose a half an inch or more over that time. And if we haven't put any control joints in, we may begin to see some hairline cracking or buckling in the stone. And so it may make sense every floor or every other floor to put some type of a control joint in. Now, we've got a detail on how that could be done if they want to, but we would recommend the designer or architect of the building decide where those go. I wouldn't make that choice as the contractor. I would ask that question back to the designer. Let's take a look at wood and steel framing now. Typical application is going to be wood or steel studs. some type of sheathing, followed by 2 layers of water-resistant barrier, or WRB, followed by metal lath, scratch coat, setting mortar, and then the stone. Now let's take a quick look inside. The NCMA does have some recommendations for interior applications, interior. If you're going to use lath and mortar inside, they recommend considering using a layer or 2 of WRB. The reason is when we install inside, we're typically putting that lath over top of plywood, OSB, or sometimes drywall. And the water that's in our scratch coat and setting mortar could potentially soak into one of those sheathings. And it's not a large possibility, but you do have the potential for mold or mildew. And everybody, for the right reasons, is pretty hypersensitive about that. So putting up a cheap layer or 2 of a water-resistant barrier will help to avoid that issue. Inside, if you want to use cement board, that's absolutely fine. You could use a layer of water-resistant barrier behind if you want. The important things are to make sure that the cement board you're using is a proper, at least half-inch thick cement board. It needs to meet, there are some ASTM specifications. We don't want to use a quarter-inch thin board. We need to make sure that all the seams and joints have been taped with at least a 2-inch alkali-resistant tape for interior. And we're using a proper modified mortar to tape in the joints and to set the stones. And we'll talk more about that modified mortar later in the presentation. Let's go outside now, exterior. We talked about the 2 layers of paper, the metal lath and the scratch coat. If you want to use cement board outside, again, that's absolutely fine. Make sure that you have sheathing, followed by at least 1 layer of a proper WRB, followed by an exterior grade cement board. Again, you can find the proper ASTM requirements in the NCMA guide. You want to make sure now that you're using a 4-inch wide alkali resistant tape, and again, it needs to be a proper modified mortar to set that tape and to set those stones. But cement board is a great option to avoid using metal lath with all the work that goes into that and less chance of cutting yourself. So when it comes to sheathings, we're seeing plywood and OSB. There are others that are out there, exterior gypsums. The one comment we would make right now is with OSB, just be careful. When that stuff gets wet, it's got a tendency to swell. If there's an area that you're being asked to install stone on that is soaked, the OSB, you may want to either go ask to have it replaced, be on record that you've asked for that, or make sure that OSB has a chance to dry out. If OSB gets wet and swells, there could be enough pressure behind the stone to cause cracking. At the bottom of any framed construction, it's required to have a weep screed. We need a foundation flashing there. Part of the requirements are a 3.5-inch leg or nailing flange, extending behind the 2 layers of water-resistant barrier. It needs to extend at least 1 inch below the sill plate. It can be vinyl, it can be metal, but the primary purposes are 1, to allow water that gets back to the paper and travels down, a place to exit the system. The other primary purpose is a capillary break. We want to make sure that water doesn't wick up into the bottom of the wall system. The papers that are in behind our stone are meant to handle water for days, weeks, sometimes at end, but eventually to dry back out. When we bury stone down into grade, water begins to wick up inside of our stone, and now water is being held against those papers for much longer than they're meant to stay wet. They eventually begin to deteriorate, and now water can begin to get into our wall system. I think this is something that we see all too often, where stone is buried down into grade, and in this case, in the mulch. We've got a couple of problems now. 1, the bugs, termites that are living in this mulch have got pretty easy access now to get into the stone, and we wouldn't know it. It's going to sit there and wick water, especially if there's any sprinklers anywhere nearby that are constantly watering this area. And then the third thing is that, again, those papers are staying wet entirely too long, and we've got potential for them to deteriorate earlier than they should. In this one, we had the same thing, stone buried down into grade. You can see the word exhibit above here, which means lawyers are now involved. And I can tell you that there are issues with code if this stone is buried down into grade. So please make sure you find out what the clearances are. We'll talk about them more later, but that we're following those. Let's have a little fun. Take a look at this picture and see if you can pick out what's wrong with it. I'll give you a quick moment to take a look and do some studying. If we were doing this in person, we probably would ask for a raise of hands and give out some wonderful prizes. So if we get back to doing this in person, please come join us. Let's them have some fun with it. So if you said the scratch coat, maybe a hair thin, but definitely doesn't have any horizontal lines in it, you'd be correct. If you said the metal lath is standing straight up and down, you'd be correct with that. That's improper. You can see almost a gap in between this transition between the two. So what's keeping water from getting in there? So we've got a flashing issue at this point. Well done. If you said we're missing 2 layers of paper, I will give you a gold star by your name. Well done for today. So yes, the requirement is for 2 layers of water resistant barrier. Typically, the house wrap, commercial wraps, liquid applieds usually fall under this E2556 or equivalent. We are looking for a second layer of water resistant barrier. The reason we ask for that, or code asks for that, is we find that mortar, when it comes contact with the primary WRB, has a tendency to bond with it. And then that primary paper is not able to do its job very well. So that secondary layer is what we call a sacrificial layer. But we don't want to just use any type of paper. We need to make sure that it meets one of these specifications. Now, there's a lot going on in this slide, so let's follow my cursor. We're going to start inside this box. Our recommendation for that secondary layer would be an ASTM spec D226, type 1, grade D, number 15 asphalt, intended for wall applications. Now, I know that's a lot of extra information, but that's what helps us separate these papers from this one over here. This picture on the right is a roofing felt. It meets a different ASTM spec, 4869. There are some roofing felts that meet D226, but they're a type 2. The problem with those papers is their perm rating. Now we're going to go back to this picture really quick. Vapors trying to get in and out of your building. Typically these papers, the primary water resistant barrier, have a perm rating between 5, 10, sometimes 20, 30, 40, or 50. They can be fairly vapor open. And if we use a roofing felt that have a perm rating of about 1 or less, the vapor that passes out of this building now can't get through that 1 or less. It's going to get trapped in between, and we've got potential for mold or mildew. We need to make sure that our sacrificial layer has a perm rating that's similar to our secondary layer. And these D226 type 1s meet that requirement. So look right on the label of the product that you're using. It should say D226 type 1 or that E2556. Let's talk about metal lath. There's a lot of different types of lath that are acceptable. Most folks are using a 2.5, self-burring, corrosion-resistant lath. We do see some woven wire from time to time. That needs to be at least an 18 gauge or heavier, which means heavier being 17 or 16. We don't want to use something that's in the 20 or 22 range. That's too light. Metal lath starts out as a solid sheet of metal. They score it and stretch it. That's what creates these diamond shapes and the cups that we see. We're all very familiar with lath. The sheets are about 8 foot long, about 27 inches tall. We do not want to start and stop at a corner. In doing so, there's great potential for cracking in our corners. 2 things. New buildings, as they settle, do not settle evenly, and that uneven movement usually shows up in the corners and can crack the cornerstones. The other problem is when the sun hits one side of the building, this wall begins to warm up and expand. And as the sun moves in the afternoon to the opposite side of the building, now this wall is warming and this wall is cooling. And that differential movement can cause cracking in the corners. And so the same thing applies for our inside corners. We don't want to start and stop. We need to make sure that we're wrapping our lath through inside and outside corners. This is what our paper and our lath should look like coming around the corner to the first framing member. If that's 12 inches, that's fine. Typically, that's about 16 inches. And we want to make sure that these seams stagger. We don't want all of our metal lath coming around just to the first framing member. Our paper should be overlapped by at least 2 inches top over bottom to get that shingle effect. And then our vertical overlaps need to be at least 6 to 8 inches. And again, staggering those vertical overlaps as they go up the wall. Metal lath should be overlapped, I would say, at least 1 inch on all 4 sides. Code specifically says 1 inch vertically and 1/2 inch horizontally. I think it's easiest to remember just a 1 inch on all 4 sides. So again, let's take a look and see if you can figure out what's wrong with this picture. I'll zoom in a little bit, give you just a moment to take a look at it. If in looking at this picture, you said, hey, there's only one layer of WRB, well done, you win a prize for today. If you said the metal lath was not overlapped, I can see gaps in the corner and then a couple of gaps over here where we'll definitely see some cracking in the stone over time on this job, you again would be correct, well done, you win a prize. If you said no scratch coats, well, we haven't talked about that, but when we just do a heavy set of mortar on the back of the stone and stick it to bare metal lath, it never covers all the metal. There's going to be some gaps. Metal lath, even though it's corrosion resistant, if exposed to enough air and moisture, will begin to rust. If you guessed all three of those, you get a star by your name. Well done today. Building code says that metal lath should always be installed horizontally, never vertically. This is required in the code. As you can see, we've got our 8-foot long, 27-inch tall. The reason is, if you remember, it starts out as a solid sheet of metal. It gets scored and stretched, and when it's stretched, that's when it gets coated with its corrosion-resistant material. That 27-inch section is the weaker part of the lath. All of its strength is horizontal. Now, in this picture, we can see two sheets standing straight up and down. I understand why the contractor did that, because if you've ever had to cut metal lath before, you know that every time you cut it, there's a better chance you're getting cut up too. And in this case, they didn't have to do that. But the problem is we don't have any proper overlap around the corner, and we're only grabbing one, maybe two studs across that 27-inch section, the weakest part. So now when a wind event happens and this building racks just a little bit, that 27-inch section area could flex and we could get some cracking in the stone. So let's make sure we're running that metal lath horizontal. Self-furring metal lath. Two different ways that it may look. One, having some V-grooves in it or a bunch of dimples in it. Years ago, we used to work with metal lath that was flat lath. It's no longer acceptable by code. The problem with flat lath is when we put it up on the wall, it was so tight to the wall that mortar couldn't get back in behind. It couldn't get fully encapsulated. And when metal lath is not fully encapsulated in mortar, it gets exposed to air and moisture and it begins to rust. Now, is there a right side up or an upside down to metal lath? Well, the code doesn't give a specific direction, but many of the metal lath manufacturers will say there is a direction to it. I was taught cups up, so I spent a lot of time looking at the lath, flipping it back and forth, trying to figure out which way the cups went. Some folks can tell by the sheen if it's right side up or upside down. Gary Malin, who was a part of the stucco industry for a long, long time, I think has a much easier to remember and a lot more entertaining quote on how to tell. If your metal lath is installed correctly, it should be like a good whiskey. It should be smooth going down and rough coming up. So as you run your hand down the lath, it should feel smooth. Bring your hand back up, it should feel a little bit like a cheese grater. Now again, the metal lath manufacturers will tell you to put the cups in the direction that you put your scratch coat on. If you put mud on your pargin trowel, set it on the lath and push it up, then your cup should be facing up. If you put it on your trowel and you push down onto the lath, going down the wall, then your cup should be facing down. I haven't seen too many folks parge down. If you do that, let me know. I'd love to see it. So let's talk about our anchor pattern. When it comes to wood framing, we want to make sure that our anchors get in by 3/4 of an inch. Again, corrosion resistant nails or staples. In order to get 3/4 of an inch penetration into framing, we need to add for the sheathing and anything else that may be outside of that stud. So you're going to end up with probably an 1.25 inches, 1.5 inches or longer nail or staple. When it comes to our pattern, we're looking for, again, 16-inch on center, about every 6 or 7 inches vertically. We don't need any more than that. All too often, and I can tell you I did it, I took the nail or staple gun and I went to town. Usually that was for a couple of reasons. One, I thought we needed a lot more nails and staples to hold that metal lath on to carry all the weight of that stone system. I will tell you that all of our testing shows that nailed on this pattern is more than enough to carry that weight, or sufficient to carry that weight. The other reason is metal has a memory, and if there's a bubble in between, we like to go through and put a bunch of nails or staples in to hold that bubble in. The problem with this over nailing and stapling is metal lath with that proper nail pattern is flexible in between these studs. And if that sheathing and wall system move a little bit, that metal lath can move independent of the wall, absorb movement, and not pass it through to the stone. But when we over nail or staple, that metal lath no longer can move independent of the sheathing. If there's any movement in the wall system, that wall or stone system will move with it, and we see some hairline or worse, some cracking in the stones and joints. So try to keep those nails and staples to a minimum. Now, when it comes to the scratch coat, we want to make sure that we're getting a full 100% coverage over the entire metal lath. It should be a nominal 1/2 inch thick. How do we know if it's a nominal 1/2 inch thick? You should no longer be able to see the ridges of a metal lath. It should be enough that you can't see the metal lath anymore. That's a nominal 1/2 inch thick scratch coat. And once that scratch coat begins to set up or thumbprint hard, as the name implies, we want to scratch it. We want to put some horizontal lines in with a 1/4 inch notch trowel or a scar fire. That gives our setting mortar some more bondable surface. When it's smooth, it can bond, but not as well as if we scratch up that scratch coat. Type S or type N are absolutely fine for those scratch coats. We want to make sure that our sand and mortar mixes are at the proper mix ratio. So if you're doing a site mix, follow C270 for your sand and mortar mix. If you're using a pre-blended bag, make sure that C1714 is printed right on the side. Your proper scratch coat's going to look a little bit like this. You can see a few spots where maybe some metal is up near the surface, but not too much. We've got that nominal 1/2 inch thick scratch coat. We use demo boards. They look a little bit like this, and I had to tear one of our demo boards apart, and I was able to pull half of this scratch coat off without doing too much damage to it. And it gave me a peek at the back side of our scratch coat. We don't see any metal lath poking through out here. We don't really see much, a little bit in here poking through. That tells us that we got about a 1/4 inch on both sides of the metal lath. Now we know it's fully encapsulated. In this picture, you can see the ridges of the metal lath poking out. It wasn't thick enough, it didn't cover, air and moisture got to the metal, and you can see the rusting that began to develop. Let's talk about some mortar recommendations. Code requirement, if you remember at the beginning, was for a 50 PSI for shear bond strength with a stone. Type N, when mixed to the proper sand and mortar ratio, will give us just above that 50 PSI. That's good, but not great. There are some better options out there, and we're trying to move the industry more towards those better options. Type S, when mixed to the proper sand and mortar ratio, starts to get bond strengths north of 100 PSI. Modified mortars, when mixed properly, start to get north of 300 PSI. So why use something that barely meets the code minimum when there's some products that get us better bond strength? And what's the challenge we have with manufactured stone? It's stones popping off the wall. So our recommendation is use Type S for interior, use it for residential applications, or maybe a commercial job if it's staying below 10 feet. Use a modified mortar for any of those applications, but we would highly recommend or require that you use a modified mortar for exterior commercial applications above 10 feet. You know, we don't want one of those stones popping off on a restaurant or hotel right over a sidewalk where somebody could be walking. That 300 PSI makes a lot of sense there. Cement board, it's required to use a modified mortar over top of a cement board. I'll tell you personally, if I was using or installing a tight fit application on a garage front, knowing that, you know, with the garage door going up and down and a basketball hoop mounted on there, there'd be a lot of jarring and movement, but also people walking and playing underneath, I would move to that modified mortar. It's a small expense for that added insurance if that stone's not coming off the wall. If you need to use some type of an admixture, cold weather application where we're trying to accelerate drying time, or hot weather where we're trying to slow it, we're not big fans of the different admixtures, but if you have to use it, just make sure you follow that manufacturer's recommendations for how much diluted and when it's used. The caution around cold weather is those admixtures do not lower the freezing temperature of your mortar. All they do is accelerate the drying time. I've seen some guys try to use admixtures in 29-degree weather thinking that their mortar wouldn't freeze because they put a quote-unquote antifreeze in there. That mortar is still going to freeze. So make sure you're tenting in and heating. You just may not need to tent in and heat as long. Please don't use stones that have ice or snow or water on them, or even if they're dry, if that stone temperature is 20 degrees, they are not going to bond well and they're going to contribute to freezing your mortar. Please don't use antifreeze. If you're old enough to remember a time when we did, antifreezes have changed drastically since that time, and they now actually probably have a negative impact on your mortar. So please don't use antifreeze, and please be careful with calcium chloride and calcium nitrate. They do promote corrosion in metal. So be careful around metal door frames, window frames, and especially if you're using metal lath, you don't want to contribute to corroding your metal lath. Let's talk about tight fit installations. This is a very popular look. We don't see that changing anytime soon. Our recommendation is lay your corners first. I was fortunate, the guys that trained me were natural stone, brick, and block guys. And so we would lay our corners up first, start at the bottom, and lay our stones back and forth in courses. These guys did a little bit of that, but then they created themselves a hole. The problem with holes like this is now you've got to find the perfect stone, and you're going to waste a lot of time looking for that perfect stone or a lot of wasted time cutting. If you work tight fit applications back and forth in courses across the wall, really the only cut you should make is at the end of the wall, or occasionally if you need to throw a jumper in to mix it up a little bit. We recommend hydrating the scratch coat in stone. We'll talk about that more in a minute. And we also would suggest consider using a modified mortar for that increased bond strength. We have seen probably a few more warranty claims on tight fit installations than grouted. The reason is they don't have the benefit of the grout joint around all four sides to help hold the stone on. And so if there is a mortar or application issue with a tight fit application, they show up a little bit quicker. And I can tell you that two causes for stones popping off are sometimes mortar that gets mixed too quickly. Mortar manufacturers will tell you to mix for 4 or 5 minutes, let it rest for 2 or 3, get that false set or first set, depending on what you call it, splash of water, and then agitate for another 3 or 4 minutes. That's for your conventional type S or N mortars. That makes sure that that Portland cement gets fully hydrated, and to make sure that that Portland cement can make the chemical and mechanical bond it's intended to make. The more often reason we see stones popping off the wall is the mortar dried out too quickly. You could have a 60-degree day. It doesn't have to be hot. But if that 60-degree sun is hitting that scratch coat all day long, that wall temperature is going to be 10, 20, 30 degrees warmer than the air temperature. So are the stones. And if all I do is just put mud on the back of that stone and stick it to the wall, as soon as that stone and setting mortar hit the wall, there's a battle between the scratch coat and the stone to pull the moisture out of that setting mortar. It dries too fast in about 3 minutes, and now we've got a very brittle bond. So please, in any hot weather or dry weather, hydrate the scratch coat, hydrate the stone. You can use a garden mister, a bug sprayer. You don't want to see water pooling on the surface, but as long as it's hydrated, now that mortar has a chance to dry at a normal rate. It's kind of like concrete. The slower a concrete dries, the harder it is. The same thing goes for the bond. The slower it dries, the better it's going to be. Please don't install in cold weather, as we talked about. Make sure that mortar is protected until it completely cures. Now again, hydrating scratch coats and hydrating the back of the stone is a recommendation for grouted applications and for tight fit. And in our installation instructions, it doesn't say just for hot stones or hot weather. It really is for any dry weather application. Please cover 100% of the back of the stone with about 1/2 to 3/4 of an inch of mortar. Our stone system is built on 100% of the back of that stone bonding with the wall. When it goes up to the wall, we're going to move that stone as we set it left to right or up or down so that mortar squeezes out around all 4 sides. Probably should look a little bit like this. This is probably a little bit messy. If you've got an eagle eye and notice that there's no lines in here, well done, you get a star by your name. When we're going to grout it, we leave about 1/2 inch in between the stones, come back with a grout bag, wait until that mortar's about thumbprint hard, hit it with a wooden stick or a metal striking tool and a brush to finish that joint. Again, if you've got an eagle eye and see that that scratch coat's a little bit thin with no lines and even looks maybe wet, well done, you get a star by your name. Now, incomplete coverage on the back of the stone can lead to stones popping off the wall. If you're in a cold weather climate or a hot weather climate, our stones are masonry. They will absorb water and they will pass water through, just like brick does into an air space. if there's an airspace behind our stone, it could pass in here and begin to puddle up. And if you're in a freeze-thaw environment, you're going to begin to push stones off the wall. In this case, it could have been that, or it could have been mortar that was too dry. You get sitting out on your table for too long. Those last couple of trowelfuls of mortar are so dry that you got to kind of force them onto the back of the stone. You know that that mortar dries too fast and stones could pop off. Now I'm showing this one more time because I'm about 5 floors up on top of a hotel. This is where you do not want stones popping off. You don't want them popping off anywhere, but this is where it gets really dangerous. And again, if you think we're looking for 100% coverage on the back of the stone, bonding with 100% of the wall, I am lucky if I'm getting 30 or 40% bond right here, so we can see why those stones were popping off. An idea might be, especially if you've got larger crews or newer guys working for you, random check. Go through and pop a stone off every once in a while, every couple of hours, to make sure your guys are getting full coverage. Now, if you want to use a protective treatment, I try to avoid using the word sealer because then homeowners start to think Thompson's water seal or something like that, which is bad for masonry because it's a full face sealer. Just make sure it's a silane or a siloxane base breathable coating. Just beware to test it first because it may darken the color or give it more of a wet sheen, which some people want, and that's fine. It also does help to increase the stain resistance or make that stone a little bit easier to clean. Again, any silane or siloxane based product will be fine. Boral does produce one or sell one called Craft Shield. Would be available at any place that sells one of our stones. We're on to our last topic or two here. We're going to look at efflorescence. Efflorescence is caused by latent salts, could be in a CMU, in a mortar or a stone. You also need excessive amounts of water, more than just hits on the face of the stone. And then you need it to dry and pull those salts out and deposit on the face of the stone. Now, in the picture that we see here, we don't see any efflorescence back here. There's none on the building. This is a CMU wing wall, and we really don't see it over here. It's just in this one spot where this rainwater coming down this roof line didn't get caught by that little gutter. And then as we zoom in a little bit, you can see that there's no cap on top. The contractor just feathered some mortar on there. We know that cracked way, 6 weeks after it was there. And so now all that running water that didn't get caught is getting drawn inside of the CMU, and it's carrying the salts out of the CMU or mortar deposited on the face. Now, the nice thing about the Boral Stone brand products is that we have done things in our mix to kind of tie up the salts. We use better aggregates too. That way, don't usually see efflorescence in our stone, but if you do, typically there's a water management issue, and we would suggest fixing that first, and then allow that wall system to dry out. And then usually you can take a dry brush and brush off that efflorescence. If it's a little harder to clean, you can use a 1 part vinegar, 5 part water solution. Please do not make that solution any higher on the vinegar side, then it becomes a little too acidic and you could affect the color negatively. So 1 part vinegar, 5 part water, soft bristle broom, scrub off the efflorescence, and then immediately rinse that off. Lastly, we want to talk about cleaning stone. The guys that trained me said, well, if you're going to talk about cleaning stone, why don't you first talk about how to keep your stone clean? And I think that makes an awful lot of sense. When I was tending, my job throughout the morning and especially at lunchtime as the guys walked off to eat their lunch was to take a soft bristle broom and go through and clean the stone off. If you're using a conventional type S or type N, a little bit of mortar splashes or smears on a stone, if you let it sit for about a half an hour to an hour, depending on the temperatures and all that, it starts to turn white and you can brush it off immediately without any negative effect left behind. If you wait until the next day, it will leave a stain and you're not going to be able to get it out. So again, my job as a tender was throughout the day, brush it down, lunchtime, a really good job of it. And then at the end of the day, as they hop in their trucks and I'm cleaning up, my job at the end of the day was to go through and brush it down one more time. We never had any callbacks for fingerprints and mortar smears that way. So when it does come to cleaning some dirt and dust, warm water, mild detergent, soft bristle broom will take care of most things. Please, no acids, no power washers, no metal brushes. I included a picture in here. This here at the top, I should first start by saying this entire fireplace has stone installed on it. This is what the stone looked like. This is what it looked like after somebody decided to use acid to try to clean the stone. The stone is still there, but it took all the color out of it completely. So please, no acids when you're trying to clean the stone. That brings us to the end of our first half of our presentation that we'll pick up again next week, but I'd like to pause and see if there are any questions that may have come in.
All right, Jeff, we got two so far. The first one lands in the WRB section of the presentation, and it has to do with lapping. And the question is, do the house wrap materials have the same lapping requirements as felt?
So I would say in most cases they do, but the important thing would be that primary to follow the manufacturer's instructions for a primary WRB. Again, that's doing all the heavy lifting. And more often than not, we're seeing those with some requirements around taping, around specific nails and caps and covers, because again, that's what's keeping a lot of the air and water out of that system. So yes, there may be very similar to what we do with the number 15 felt, but I would suggest conferring first with the manufacturer of that product to see how they recommend doing it.
The second question is more asking for advice. This person says, when I install tight fit, it's common that I bump a previously installed stone and ruin the bond. Do you have any advice for me?
Yeah, I can tell you that's happened to me more than once, especially when you've got that homeowner looking right over your shoulder with a hold of the catalog picture showing those stones perfectly tight together, and you're trying to give them that look. Conventional mortars like Type S and Type N, when they set that bond and you come in with the next stone and you accidentally tap it just a little bit too hard, it's very easy to break that bond. And so the best thing to do is to pull that stone out, clean it off, and reset the stone. One of the recommendations would be to consider using a modified mortar. Modified mortars have a much longer open time. And so let's say you're doing a tight fit installation, you will go through and put a little bit of that modified mortar on your scratch coat, put a little bit of the modified mortar on the back of your stone. And in that situation, depending on the brand, you could have 5, 10, 15 minutes of additional open time. Whereas your Type S and Type N, as soon as you stop moving, you can't move it anymore. But with a modified mortar installed in that method, you could have 5, 10, 15 minutes that you could go back and make an adjustment. So if you accidentally bump the stone, you could fix it without pulling it off. Or if you decide, hey, I need to move this stone over a 1/2 inch or a 1/4 inch to make it fit a little bit better, you can do that too. So another reason to consider using a modified mortar above just the additional bond strength that you get with it.
Good. And the last one has to do with a request, and I don't know that you'll be able to show this on screen, but I think you've got the web address now on screen. So if someone wanted to see a good detail for where stone comes down to roofing, where would you find that?
Yep, that's a great one. So you could go out to any one of Boral's stone brands, and on our website under the installation instructions, you're going to find the NCMA-MSV, or Manufactured Stone Veneer, installation guide. You could also navigate out to the ncma.org. I would suggest you just come back and see us next week on Tuesday or Thursday, because that's one of the details that we will specifically address, different options. And to be honest with you, we're also going to show a couple of photos of the mistakes that could be made and the negative impact that it can have. And so the importance, extreme importance of that transition of stone to a roof line. So if you get the opportunity, come back and see us again next week.
Since you got a couple minutes left, one more question came in, Jeff. It says, many builders like to leave a small foundation at the bottom of the wall where the weep screed should be. They want the stone to look like it sits on the foundation like a full thickness natural stone. Is that allowable, and would it drain the wall?
And so I think if I'm understanding correctly, you've got a foundation that maybe had a brick ledge poured into it. And if that foundation, that brick ledge foundation, is part of the foundation of the wall that the stone is on, then technically you could still come down to within half an inch. Now you're still going to need to keep grade down because you don't want to cover that up and have water wicking up into the wall system or give easy access for bugs. But Chris, correct me if I'm wrong, the way I would read that is you would still need to terminate with a weep screed, but could bring your stone down to within a half an inch.
I agree. Yeah, your key question or your key point there is, where is the earth or where is the mulch still? Yep. That is the last question we have, Jeff.
Well, I will just say for myself, I really appreciate everybody's time tonight. I hope that you found value. Please reach out to us. Chris, were you able to put email addresses into the chat box there?
I will do that right now.
Chris is going to add our information there. If there's questions that you didn't get a chance to ask about or come up later, please don't hesitate to reach out to us or any one of your Boral representatives that are out there. They do a phenomenal job. We're here to support you. Thank you very much for all that you do. And again, thank you for your time tonight. Stay safe, and we'll talk to you later.